These are the first 4 problems that are on the worksheet that you have to do. It says Quadratic Practice. And I'm going to guide you through all 4 of these. However, we're going to do it differently in the video than we did it in the lesson. In the lesson, we did each problem, and what we're going to do in this one is actually do each component at the same time. In other words, we're going to do all the X-intercepts at the same time, all the Y-intercepts at the same time, all that kind of stuff. First thing we need to do, I dropped a pen, I don't need that one anyway, it doesn't hardly write. First thing we're going to do is identify with these 4 what type of equation it is. This, we'll come back to him. This one has a very easily identified vertex. I know it's in vertex form because it has the parentheses and it's squared. And so I'm going to go ahead and say that this is in vertex form. Because that's actually one of the first things it asks. This one does not have an easily identifiable vertex because it's nothing in parentheses that is squared. Now we do have a squared, but that makes it quadratic because the highest exponent is a 2. Nevertheless, it clearly doesn't have the parentheses with the squared. So this one actually is in standard form. And this one is in standard form as well. Okay, back to the first one. Is this one in vertex form or standard form? And there was one like this in the notes, but actually, I'm stuttering. Basically, this is both. This is both vertex form and standard form. If I looked at you and I said, is this in standard form? You could say yes, because actually this and this look like that. The only difference is, technically, there's like a plus 0x right there. Also, it is in vertex form because if I said, hey, what's the vertex? You could say very easily, it's 0, -4. I'm going to write it both ways really quickly just so you can kind of get a glimpse of what it looks like. And when I do that, you'll be able to see. This is okay. It is vertex and standard form, and I'm going to go ahead and write both. This is in both forms. One of the few that can be both. By the way, if the B component is 0, it can be both. But if you want to get really technical about it, vertex form would look more vertex formish if we did that. And standard form would look more standard formish. I just made a huge smudge. If we did that. So this is right, this is the same thing, this is the same thing, but that looks more like vertex form, that looks more like standard form. Okay, so let's go through here and convert everything to vertex form. That one's good to go. Again, I'm doing the same thing consistently throughout on all 4 problems. So we're going to go through now, put everything in vertex form. This one's in vertex form, this one's in vertex form, this one's not. Let's put it in vertex form. This was the crazy stuff that we did. So we're going to go to vertex form. When we do that, we have y equals 1/2 x squared minus 4x, and we're going to put plus 3 way over here. Why did we do that? Because we need a gap there. We're going to fill in that gap with a blank in a minute. First, though, here's the real problem. We have a 1/2 that is in the way. Do you remember the warm-up that we did yesterday? Just don't write this down. Remember the warm-up we did yesterday where it was like x squared plus 6x plus something? That's what we're going to do. That's the exact same thing we're about to do. Only in all of those, we did not have a coefficient other than 1. So we're going to have y equals 1/2, and then we're going to factor it out. So x squared, 4 divided by 1/2. 4 divided by 1/2 is not 2. 4 divided by 1/2 is 8. If I have $4, I have 8 half-dollars. So minus 8x. Plus something. And what is that something? I do know. I was about to say I don't know. But we'll figure it out in a second. We're going to add 3 right here. Now, we're going to put something in this blank. And because we're putting something in that blank, we're adding something to the right side. So we better add something to the left side to make them equal. Okay, what goes in this blank? Let me pick up my red pen and I'll tell you. The number that goes in this blank, is what I do is I take the number with my x, then I half it, and then I square it. And that gives me 16 right there. It does write pretty well. I did not add 16 to the right side. I added half of 16. So in this blank, I'm going to put an 8. And now they're equal. We have balanced this equation. It's still good. Let's keep going with it. we still have y plus 8 over here. And we're aiming for vertex form. Equals 1/2. We're going to factor this. When we factor it, we could write it as x minus 4 times x minus 4. The quantity here and the quantity there. But because it's the same thing, we'll do that. Well, you know what? We're almost at vertex form. We're going to subtract 8 from both sides. We'll subtract 8 from that. I'm going to save the space and not even show that step because I'm going to need all this down here too. Y equals 1/2 x minus 4 squared and then minus 5. There we go. We now have it in vertex form. Let's keep going. Let's do the same thing here. We're going to go a little bit faster. We need y equals negative x squared minus 2x. Leave a little gap. I only leave a gap because I'm trying to keep in mind that I'm going to need to put a plus blank there in a minute, and then minus 8. Okay, we have a problem. Our problem is that that is not a 1. If it was a 1, life would be easy, but this one is not easy. We're going to have to factor out a negative 1 from these two terms, not that one. Notice we didn't factor 1/2 out of that 3. That's why we moved it over so we would not be factoring that a coefficient from it. So we have x squared, and then we have negative 2 divided by negative 1, which is positive 2x plus blank. I know what goes in that blank. You probably know what goes in that blank, but let's leave it as a blank for now. Okay, we are about to put something in that blank. We have to balance it out on the other side, and so you have y plus something. I take the number with my x, then I half it, and I square it. 1 squared is 1. Boom. I did not add a 1 to the right side. I really added 1 times negative 1. Technically, these are multiplied together. So this is really a negative 1 right there. Okay, let's keep going. We're turning this into vertex form. So we have y minus 1 right here. We still have a negative in the front. Comes from that one. And we're going to factor that. If we factor it, it would be, you can kind of picture this in your head, x plus 1 and x plus 1. X plus 1 times x plus 1 would really just be x plus 1 with the quantity squared. There we go. We almost have it in vertex form now. Y equals negative x plus 1 squared. We're going to add 1 to both sides. We're adding to that right there, and there it is. So, we have all 4 equations. Again, I'm doing all 4 problems simultaneously, doing each component at the same time. A little different than we did it in the lesson. We have all 4 problems in vertex form already. So let's go through here and let's identify what the vertices are. So the vertex here, the vertex on this one is at 0, negative 4. Now, I could look up here and say that it's 0, negative 4. I can't look here and say that it's 0, negative 4. No, that doesn't work right there. Not really. I can look at this one and tell what the vertex is. The vertex here is 4, comma, negative 1. Always disobey the sign on the inside. The vertex here is 4, negative 5. The vertex here is negative 1, negative 7. Okay, we have found vertex form for each of them. We have standard form for this one, and this one. We never found standard form for this one. And this is one of the easier problems. It's just kind of basic algebra. So, real quick, just so we can know what's what, we've labeled our vertex. I am going to draw a little arrow here, and I'm going to say that that's vertex form. Just so we'll know what that is, I'll go ahead and draw that one there too. So here's the vertex form for this one, here's vertex form for that one. Let's keep going. We have yet to put this one in standard form. Again, we're going through and we're converting them. Whatever it was, we're writing it as the other. This was both, so we didn't have to mess with it. These were in standard, so they went to vertex. This is vertex, so it goes to standard form. What I'm going to do is take this equation and we'll bring it down here. And I'm going to just keep on going with it. So we have y equals 1/2 x minus 4. Because it's squared, I'll put it twice. X minus 4 and then minus 1. We're going to FOIL. What about that 1/2? Make him wait. Make him wait. So y equals 1/2 x squared minus 8x plus 16 minus 1. we have y equals 1/2 x squared minus 4x plus 8 minus 1. I'm going to save a little bit of space because you know what's about to happen. By the way, we just distributed the 1/2. These are like terms. 8 minus 1 gives me 7. We now have this one in standard form. Okay. Fantastic. Let's start finding some other stuff. Let's go for the easy one. The easiest thing you can ever find, once you have standard form, is to find the y-intercept. The y-intercept is what you get when you plug in 0 for x. In standard form, that works out so simply. We talked about this in class. If I plug in a 0 for x right there, this term is gone and I have a -4. So, with my red marker, I will say that my y-intercept here is -4. You know what I'm going to do? I'm going to get a little bit tricky, not tricky, I'm going to get a little technical. The y-intercept is a coordinate. Because it's a coordinate, I'm going to write it as 0, -4. That's the same as the vertex, dang right, in this case. The y-intercept here is going to be the 7. Because I plug in a 0 here and a 0 here. So it's 0, 7. The y-intercept here is going to be, I'm going back to standard form. You can plug in the 0 here, it takes a little bit more work. Let's come up here. If I plugged in a 0 here and a 0 here, I'd be left with the 3. It's always the C value. That's A, B, and C. So it's 0, 3. The y-intercept here is 0, -8. There we go. Okay, pardon the bad grammar at the top of that column where it says, what are the y-intercept? Actually, I had typed, what are the y-intercepts? I realized you'll only have one y-intercept. Otherwise, it would not be a function. Okay. We have yet to draw a rough sketch. We haven't determined if it's a maximum or minimum. We'll get to that. Let's find the x-intercepts. This is the crazy part. This is where you have to use the quadratic formula. This one's going to take a little bit of time on some of these. This one's going to be the easiest one. The x-intercepts is what you get when you plug in y. At the y-intercept, x is 0. At the x-intercept, y is 0. So what we're going to do is plug in 0 right there. So for my x-intercept, I know this is getting kind of jumbled, but I'm trying to just kind of keep it all going. So for my x-intercept, I'm going to have 0 equals x squared minus 4. That's fantastic. What we're going to do is add 4 to the other side. And we'll take the square root, and we have plus and minus 2. If you want to get picky about it, you don't have to, but if you want to get picky about it, you can say that my x-intercepts are the coordinates plus and minus 2, 0. So it's 2, 0, and -2, 0. So those are my x-intercepts. Let's go to the next one. The x-intercept on the next one is going to be found by using the quadratic formula. It's probably going to be very messy, but that's okay. There's A, there's B, there's C. Let's do it. For my x-intercept on this one, I would start, at least in my head, by saying that this is 0. That's 1/2 x squared minus 4x plus 7. And we're going to find x. There are several ways of doing it. Sometimes they factor, sometimes they don't. Off the top of my head, I'm pretty sure this one does not. Let me glance for just a second. No, that one does not factor. There's no way that one will factor. You can do all kinds of other things. You can actually graph it, but you won't get the exact value sometimes. The best thing to do is quadratic formula. So we will just say -b, opposite of b, plus or minus the square root of b squared minus 4, ac, all divided by 2a. Let's start cleaning it up. From the inside out. You know what that denominator is. 2 times 1/2 is 1. So we have 4 plus or minus something. You know it's over 1. All right. 16. 4 times 1/2 is 2. 2 times 7 is 14. We have 16 minus 14. That's 2. And if you want to get technical about it, let's do get technical. I'm going to erase that a little bit. I could just erase that part where it says over 1. I'm going to go one more step with it. 4 plus or minus square root of 2. I almost said that is. That's bad grammar. Those are. That is plural. There's a plus and a minus. Those are my x-intercepts. Here they are. My x-intercepts are at 4 plus square root of 2, comma 0, and let's put it together. 4 minus square root of 2, comma 0. We have found our x-intercepts. Next one. Does this one factor? This one does factor. It does. How beautiful. Should we factor it? No, let's not. I'm debating it. Give me about 2 seconds and I will think about whether or not we should. Nah, let's not. If you wanted to, you could multiply the whole thing by 2, wipe out that fraction, and it does factor. I'm not going to go there though. However, we will find the x-intercept by saying 0 equals 1/2 x squared minus 4x plus 3, and then we'll use the quadratic formula. Sorry, I had to step back and make sure it was still recording. Sometimes it stops recording and I don't even know it. I'm just talking and it's not even recording. Anyway, still going, obviously, because you're still watching it. By the way, if it factors, you get rational roots. Rational meaning you don't run into square roots like that. 2 times 1/2. Okay, we have 4 plus or minus. On the bottom you have a 2. Whoops, 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 whoops. No, you don't. You have a 1. My bad. 16. 2 times 3 is 6. 10. You know what? This one doesn't factor. I thought it would. I was pretty sure it did. Yeah, I might have done something wrong. Give me just a second. I'm thinking. 2, 3, 6, 16. I'm square root of 10. Something's not jiving here. Something is really not jiving here. Oh, it doesn't factor. It does not. Okay. I had a little brain fart right there. I apologize. Nevertheless, we have 4. Glad I didn't go that route. My word, I'd be embarrassed right now. I'm wasting your time. I did something in my head that didn't quite work. That's not the first time that's happened. But there we go. There are your x-intercepts. Okay. One more. This one does not factor either. Don't take my word for it. Let's find the x-intercepts. We're going to say 0 equals negative x squared minus 2x minus 8. Do I have to write that step? No, but that is what leads us to the quadratic formula. So negative b, opposite of that, plus or minus the square root of b squared minus 4ac. Ask me one day. I'll tell you where this formula comes from. They didn't just make it up. They who? This formula, thanks for asking who they is. This formula, I'm trying to remember who came up with it. I think the Greeks did, and it was preserved throughout the Crusades. There were a lot of Arab conquests in Europe. Let me get back to work. There were a lot of Arab conquests in Europe, and because of the Arab influence in Europe at the time of the Crusades, there was, hold on, let me try to do 2 things at once here. 32. Because of that, there was a lot of preservation of the things that the Greeks had studied centuries earlier, and a lot of the library from Alexandria, huge library, massive amount of knowledge, like the biggest amount of knowledge that they had accumulated up to that point. And that was preserved through a lot of the Arabs that had settled in Spain, particularly, and a lot of those other regions in Europe. Now you know. 28. Actually, negative 28. Oh my goodness, we're taking the square root of a negative number. That's awful. That's okay. It's actually okay. When we take the square root of a negative number, it is imaginary, which means this one will not cross the x-axis. I am not going to write this as an x-intercept. I'm not going to write it as a coordinate. Let's go 2 plus or minus. Let's see. 28 is 4 times 7. Doing this in my head. Kind of picture it as I say it. 28 is 4 times 7. Square root of 4 is 2. Square root of 7 is irrational, and it was negative, so we're going to put a little I right there. And that's over negative 2. Let's keep going. Almost out of room on this one. We're going to divide everything by negative 2, meaning we have negative 1 plus or minus 1. There we go. When we divide plus and minus by negative, it really is the same thing. Okay, so there we go. Those are our x-intercepts. which, long story short, means that's fantastic and that is correct. But if you want to get technical graphically, there are no X-intercepts. I abbreviated that a lot. Okay, we have two more things to do. Let's do the easy one first. Let me make sure this thing is still running. Indeed it is. I have no way of checking, unless I walk back and look at it. Let's do the easy thing first. There's a question that says, is the vertex a maximum or a minimum? Here it is. If my graph goes like this, the vertex is a minimum. If my graph goes like that, my vertex is a maximum. Okay, the A value, whether you're in vertex or standard form, determines whether or not it opens up or down. If A is positive, it's opening up. So, A is positive, positive, positive. So for all three of those, it's opening up, and therefore your vertex is at the minimum, it's a bottom. So I'm going to point at this, and I'm going to say it's a minimum. Where's my vertex on this one? There it is. This one is a minimum, and my vertex is here, and this is a minimum. It's getting sloppy, isn't it? That's why you have a chart. My vertex over here is a maximum, though, because that negative turned it upside down. So this is a max. Okay, we have one more thing to do, and that's draw a graph. It does not have to be perfect. Here's what I'm looking for. Is it facing the correct direction? Is the vertex in the correct quadrant? Are your X-intercepts and Y-intercepts in the right place, mostly? Let me show you. Let's graph this one. Where's your vertex? Your vertex is at 0, -4. Where are your X-intercepts? -2 and +2. Your Y-intercept is the same as your vertex. You know it opens up, so there it is. That's not a very pretty parabola, but that's pretty much what it is. All right, next one. Where's your vertex? 4, -1. 2, 3, 4, -1. I know it's right there, right about here. Okay? Does it open up or down? Up. Where's your Y-intercept? 7. 1, 2, 3, 4, 5, 6, 7. I know it better touch here. It better bottom out here. Where's your X-intercepts? Not going to get too picky. Don't panic. I know somewhere in between here and here I better cross the X-axis. So let's just do it. Let's just draw it. There we go. Keeps on going. I'm not going to get too picky and say, well, you know, that looks like it crosses at 2, and that's not exactly 2, and let's not get that crazy with it. Is your vertex in the right spot? Is it open in the right direction? Where's your Y-intercept? Now, if you'd have had this thing open and all crazy and somehow it crossed down here, that'd be wrong, because it crosses at 7. All right, next one. Vertex, 4, -5. 1, 2, 3, 4. 1, 2, 3, 4, 5. That's what I mean by a rough graph. Y-intercept is at 3, so it better not be crossing down here. When you're graphing your Y-intercept here, don't put it down there. You better be putting it 1, 2, 3 right about here, right there. Okay. There it goes. Goes through there. This one better be upside down. It better go through -1, -7, about right here. That's your vertex. Your Y-intercept is at -8, so it crosses there. Here's what's happening. It is upside down. There's your vertex. I hope y'all can see that. There's your Y-intercept. And because it does this, notice that it has no X-intercept. It never crosses the X-axis, which is why that was imaginary in the first place. There we go. There's the first 4. I know that took a while, but I tried to walk you through each individual component of the first 4. I hope that was helpful.